So hello everyone. In this current video we'll be discussing one of the very anticipated topic in organic chemistry. We'll be learning few rules that will directly help us to determine aromaticity for a given compound. Whenever we come across this term aromaticity, we generally think of three fundamental types of aromaticity, which includes aromatic compounds, non-aromatic compounds, and anti-aromatic compounds. Generally, when we are discussing these three different types of compounds or organic structures, there are few rules which are to be obeyed to classify the given compound or the given question into these three subtypes. The terms that are to be kept in mind involves the very first term. Cyclic is a must. It means your structure has to be cyclic. Always keep in mind this fundamental thing, that whenever we say cyclic is a must, we mean to say that our structure will either be aromatic or my structure will be anti-aromatic. But for the structure to be non-aromatic, it is not essential that it has to be cyclic. Even a non-cyclic structure, generally we use the word acyclic, can also be non-aromatic. So this is the first and the foremost thing that we should remember, that if at all we are using the word cyclic, generally it can have all the three possibilities: aromatic, anti-aromatic and non-aromatic. But if at all, very precisely, we are talking about acyclic or a non-cyclic structures, be very accurate in answering, it will be non-aromatic. So this is the first fundamental base on how to differentiate between two fundamental classes set, whether it is aromatic, anti-aromatic, or it has to be non-aromatic. Now, as we all know that whenever we come across this term aromaticity, there are four fundamental terms, words, or rather to say rules that are to be remembered, of which the first across which we come is the molecule must be flat. So whenever we say the molecule must be flat, means, in other words, simple words or the words that are used in organic chemistry, it has to be planar. If at all the molecule is planar or flat, it will always correspond either to aromatic or to anti-aromatic. But be very clear in understanding, if we say the molecule is non-planar, then in most of the cases that molecule will be non-aromatic. If a molecule is non-planar, it will be non-aromatic. So we can point it out as condition number 1. Coming to point number 2, or rather to say condition number 2, we will always mention conjugation. In other words, we can also mention it as alternative pi bonds. If such kind of structure is observed, it has to be aromatic or anti-aromatic. So these two are the fundamental set of conditions. It has to be planar to be aromatic or anti-aromatic. It has to have conjugated double bonds or conjugated pi bonds to fall in the category of aromatic or anti-aromatic. Now let us add two more conditions to it. So the first condition that I said over here, and just mention it again, planar. Second condition is conjugated pi bonds. Whenever we use the word conjugated pi bonds, always mention it as alternative pi bonds. Remember one very important thing that I am going to discuss with you. Sometimes negative charge under special condition can be consistently assumed as or can be estimated as equivalent to pi bond. The reason is it will form a pi bond. So these two are the basic conditions. Now condition number 3, the most important condition, is 4n plus 2 pi electrons versus 4n pi electrons. If your structure is planar, if your structure has a conjugation and your structure obeys the rule 4n plus 2 pi electrons, in most of the cases the molecule has to be aromatic. But if your structure is planar, it has a conjugation and it obeys the 4n pi electron rule, it will fall in the condition anti-aromatic. So these are the two basic difference when we try to select a molecule based on its aromaticity or anti-aromaticity. Your main focus should always be on these rules. These rules will decide in which category you wish to place the given molecule, the given organic compound. Friends, remember, if we are talking of a molecule which is non-aromatic by nature, the first and the foremost condition of being planar will be eliminated. The compound will not be planar. And if the compound is not planar, then and then only it falls in the category of being non-aromatic. So when can a compound be non-aromatic? When can a compound not be planar? When it has a minimum of 1 sp3 carbon in general. When it has a minimum of 1 sp3 carbon in general. In whole set of a molecule that is given to you, if at all you find a single molecule or a bunch of molecules having at least one carbon atom with sp3 hybridized carbon, be very precise, don't think too much. Until and unless aromaticity is concerned, you can directly opt for the option non-aromatic. So this is the point, this is the junction from where our rule book will start. So let us start with our first rule over here. If at all I am giving any set of question to you, or we are given any set of question, the very first question that we should ask to the molecule is, are you having at least one sp3 carbon. If the answer to the above question comes yes, then no need to think too much. The given molecule without any doubt is anti-aromatic by nature. But if the answer over here comes no, then what are the minimum criteria it should obey? The first and the foremost criteria that it should obey is it has to be flat. In other words, what just now we deduced, it has to be planar. Above being planar, it has to have alternative double bonds. So whenever you spell this word alternative double bonds, always say conjugation. So these are the two minimum criteria it should have: flat or a planar molecule, alternative double bond or a conjugation. If these two minimum conditions are fulfilled, then you come to another set of classification from this point, where you will fundamentally spill the beans. You will come up with two answers. One will be aromatic, second one will be anti-aromatic. And to fulfill these two answers, you have two conditions to come up with. If you are saying aromatic, it should fulfill the 4n plus 2 pi electrons. Now remember, pi electrons in organic chemistry can be fulfilled by two parameters. One, a pi bond itself. A pi bond itself will always lead you to 2 pi electrons. Why I am saying like this is because there is another option available with you, which always I have mentioned as a negative charge. This negative charge will again give you 2 pi electrons. So keep these both things in your mind whenever you are attempting for such type of question. I will give a small proof of this. If I have a carbon-carbon double bond, you are very much aware that one bond, which is pi, if breaks towards the carbon, then suddenly in this molecule you will find a change like this. So you can see this pi bond itself got converted into a negative charge. Therefore, whether it is a negative charge or whether it is a pi bond, we can always consider it as 2 pi electrons. I hope you are getting it. Especially we are meeting after a huge break on this particular platform. But as we are back, we are continuing with the same thing what we were doing earlier. Now, if at all I am concentrating on anti-aromatic, I will always focus on 4n pi electrons, and over here two things are mandatory. For this particular formula, n can be 0, 1, 2 up to n, and for this particular set of formula, n starts from 1 to up to n. So this is the basic difference. I hope you are clear with this particular page on the board. Why? Because this will help us solve each and every answers on what we are working. I'll just repeat it once and then I'll move ahead. The first and the foremost question that we ask to any organic structure we are given is whether you have a sp3 carbon. If the answer comes yes, then no need to think of any chemistry, directly go for a non-aromatic structure. Judge that structure as a non-aromatic. But if my answer comes no, then first of all I have to see for two minimum conditions, and that is the structure has to be planar, it has to be hyperconjugation or a conjugation in it. This conjugation, that is the formation of alternative double bonds, will help me decide whether the structure is aromatic or the structure is anti-aromatic. If at all the structure is aromatic, then it has to follow the rule 4n plus 2 pi electrons, and if the structure is anti-aromatic, it has to follow the rules 4n pi electrons. So, based on these set of rules, let us now start solving the questions, some basic questions, and then followed by applied questions. So let us start with the basic questions. So the first and the foremost question that we will try to discuss over here is in the same method. Let us start with the first question over here. So the first question that I am coming across is a set of cyclic structures that have only 3 carbon into consideration and not more than 3 carbons. I have 5 different structures. For ease, let me name them as, let me just name them as A, B, C, D and E. First and the foremost thing that we should know is, are all the structures cyclic? We will very precisely give the answer to this, that structure number D is acyclic. So if the structure number D itself is acyclic, no need to think anything on it, it will directly become non-aromatic. Now you are left with 4 different structures, and the second theory comes into existence. At least a single sp3 carbon. What should be your answer whenever we say a single sp3 carbon? This particular carbon has 4 valencies, and all 4 valencies are satisfied by sigma bonds, valency 1, 2, 3 and 4. So when all the 4 valencies are satisfied by sigma bond, no need to think much, it is an sp3 carbon. So at least a single sp3 carbon, if present and we say yes to it, then no need to think any damn chemistry, it will be non-aromatic by nature. So this particular structure which we are discussing has now become non-aromatic. I hope you are getting it. Can we find any other structure which is non-aromatic? Definitely yes. All these 3 carbons are fundamentally sp3 by nature. And again, if these carbons are sp3 by nature, the answer to it is the same, non-aromatic. So now we are only left with these 2 structures. Very, very important chemistry comes into it. Let us first check for structure number E. Friends, I am reapplying this structure over here, where we can see that there is a presence of a negative charge. Sometimes when we find a negative charge, what generally we think is, and we are absolutely right on the basis of the basic chemistry that we have, that you have a hydrogen, and this particular negative charge which I have, what is that particular negative charge? I will tell you. Pardon me, because this is the first time I am recording on this new platform, so might be I'll be little low in the technology, but nevertheless I'll come up very quickly, don't worry. If there is a negative charge, I can mention it by a lone pair. So if at all I am mentioning it by a lone pair, and you consider the structure similar to that of ammonia, where you have one lone pair and three bond pairs, there are three bond pairs and one lone pairs, and fundamentally this can be sp3. And if this again is sp3, you will get diverted towards non-aromatic. But friends, be very precise for this particular topic, aromaticity. That is, this has to be your main note. In the topic aromaticity, if at all there are no sp3 carbons, there are no sp3 carbons, and the only sp3 carbon that is present is because of the negative charge, then a very popular word in science, ignore it. Just ignore it. Do not take it into consideration. If at all there are no other carbon which are sp3 by nature, the only carbon that is sp3 by nature, if it is negatively charged carbon, ignore it. Don't consider it to be sp3 for this particular topic, for the vision of aromatic, non-aromatic and anti-aromatic. And if you do so, what are the total number of pi electrons you have over here? 2, and one negative charge is again equal to 2 pi electrons. So the total number of pi electrons you have over here will become, my dear, 4 pi electrons. Leave it as such. And if you focus on this particular structure, this carbon is sp2, this carbon is sp2, this carbon is sp2 because it's a carbon with a positive charge, it is sp2. Now all the carbons are sp2, so either it will be aromatic or it will be anti-aromatic. So check for the pi electrons, only one pi bond, so you will only end up with 2 pi electrons. Now check for the two formulas that you had. 4n plus 2 pi electrons and 4n pi electrons. If at all I place n is equal to 0 over here, then this whole term will become 0 and I will end up with 2 pi electrons. So the formula is getting matched with the question of my interest, and hence as 4n plus 2 pi electron rule is followed by this particular structure, this has to be aromatic. And for this particular formula, if I consider n is equal to 1, what I told you earlier in the current video, then it follows or it obeys the rule 4n plus pi, 4n pi electron, and therefore it will become anti-aromatic. So believe me, a very easy trick, a very easy method to just determine sp3 carbon, non-aromatic, sp3 carbon, non-aromatic. A positive charge, that is sp2 carbon, only by 1 pi bond, 2 pi electrons, follows the rule 4n plus 2 pi, keep it aromatic. It is anti-aromatic because 4 pi electrons, and there is a carbon which is negative, but we are not considering it to be sp3 for this particular topic, aromaticity. And henceforth, you have to consider it to be flat, consider it to be planar. Not consider sp3 carbon for this particular topic because it goes into conjugation and helps making the structure comparatively more stable, resulting into a non-aromatic structure replaced by anti-aromatic. I hope you are getting it. Let us move ahead and check for few other structures. We are just moving ahead with few other structures in this same process. A very popular cyclobuta 1,3-diene structure. Another structure, the third popular structure, the fourth one, the fifth, and the sixth structure. I have just placed 6 different structures on the board. The very first question, the very popular question that I have always taught you, discussed with you and asked you to identify is the sp3 carbon, and if your answer comes yes, non-aromatic. A plentiful of sp3 carbon. All carbons are sp3. All carbons are sp3. So it is non-aromatic. पूरा का पूरा structure non-aromatic. Both the carbons are sp3. So again it falls in the category of non-aromatic organic molecule. You can see all the 4 structures to be sp3. Again it is non-aromatic. So you can just identify these yellow color carbons which are proving itself to be sp3 and leading your structure to the non-aromatic nature. Now for this particular concept, just now we have learned that whether it is a negative charge present, do not consider it to be sp3 and do not get diverted towards a non-planar molecule. Always be focused considering it as a planar molecule, and henceforth the remaining 3 structures will at least not fall in the category of non-aromatic. So now you have 2 choices left with you. Choice number 1 is 4n plus 2 pi electron choice, that is aromatic, and 4n pi electron choice, that is anti-aromatic. 2 pi and 2 pi, 4 pi electrons, 2 pi and 2 pi, 4 pi electrons. And if you look very carefully between these 2 structures, you will not find anything that is surprising. The only thing is this pi bond has shifted over here. So you will have a negative charge over here and a positive charge over here. So in both the cases, the number of pi bond remains the same, 4 pi and 4 pi. And if the number of pi electrons remain same, 4 pi electrons, then remember very well, n is equal to 1 will lead me to the answer 4 into 1 pi. And therefore, I'll end up writing these 2 structures in very common as anti-aromatic. Now, this particular structure where somehow we are able to see 2 pi, 4 pi and 2 pi, a total of 6 pi electrons, with a query that whether it will go into conjugation or it will not go into conjugation, that is a different thing. But as of now, as we are able to see 6 pi electron with a question mark to be solved from your side, can we place it as an aromatic structure? Let's discuss in your comments. So these are the structures, simplifying our work for 4 members or 4 carbon ring structures. And let us now move ahead with 5 carbon ring structures. So whenever we have 5 carbon ring structures, these are few of the very popular structures that are possible, and we are just trying to focus on those so that we can just get an idea. If I have these 3 structures possible with me, just looking to the first and the foremost structure available, I can very well identify a sp3 carbon, and as soon as I identify a sp3 carbon present, without wasting even a fraction of second, shall we directly mention it as anti-aromatic? And your answer will be yes, 100%. Now we are left with these 2 structures where in common I can precisely say that we are missing sp3 carbon. Subject to condition, I have not considered this as sp3 carbon, the rule that I taught you just now. So directly moving for the calculation of pi electrons, 2 pi and 2 pi, 4 pi electrons, 2 pi to 4 pi and a negative charge, 6 pi electrons. Just overlooking this formula, will be very easily able to identify 4n pi electrons followed by this particular molecule and 4n plus 2 pi electrons followed by this particular molecule. On the basis of this typical answer sets, I will be very easily able to justify them as anti-aromatic and aromatic. Friends, I am quite sure that you will be learning something or other from this video class, and it will help you somehow someday to solve some question in your career. Let us add one more 5-member structure and check what can be done. A very simple structure, cyclopentane, and your straight answer will come, sir, आपका rule number 1, if you find at least one sp3 carbon, directly make it non-aromatic. सोचने की जरूरत ही नहीं है. No need to think much. Directly go for the answer. So this is how we'll just go for the answer. You will get your answer very easily. So a 5-member system that we did. Just before a 5-member system that we did, what else did we have was this 4-member system with us, and moving a step back, we could see this whole 3-member story that we did. So for 3 carbon ring structures, aromatic, anti-aromatic and non-aromatic. For these 4 carbon ring structures, aromatic, anti-aromatic and non-aromatic. And now for these 5-member ring structures, aromatic, anti-aromatic and non-aromatic. Let us move a step ahead with this very popular 6-member ring structure. The first and the foremost structure that we always come across is this. Yes, your very own benzene. Benzene, as we all know from the theory itself, it is planar. It has alternative double bonds. So ये planar भी है, alternative double bonds भी है. If we just move a step ahead and think a little bit, all the carbon present are sp2. So this 3 will directly help us lead that ये कभी भी non-aromatic नहीं हो सकता. This can never be non-aromatic. So you have only two choices left with you now, that is anti-aromatic and aromatic, and you all know there are 6 pi electrons, so it will follow the fourth rule, 4n plus 2 pi electrons, keeping n is equal to 1. And 1 यहाँ पे लगा देंगे, so 4 into 1 is 4 plus 2, you will end up with 6 electrons, and now you can very well say, yes, these are our very well known undergraduate course, plus 2 course, Yakazoo. So this is how it works. Let us add few more structures. 6 member structures add कर देते हैं. Let us add few 6 member structures. Plus and minus. As soon as I write plus and minus, remember this bond is breaking on one side. I have another structure present with me that is like this. These are called bicyclostructures. Moving a step ahead, I have many such popular structures available with us. Yes. If I have these 3 structures, what am I supposed to do? The first structure over here, what I am selecting, I will very clearly mention all carbon sp3. As soon as I mention all carbon sp3, you will not allow me to think. We will directly write it as anti-aromatic. But for this structure, it is 2 pi, 4 pi, 6 pi. And whenever the answer is 6 pi, we will directly mention it as aromatic. And on the other side, 2 pi, 2 pi, 4 pi. And in this very particular case, as it is 4 pi friends, just now we have done that when it is 4 pi, it will always be anti-aromatic because it follows the rule 4n pi electron where n is equal to 1. So this is all about a 6 carbon ring structures drawing our attention towards aromatic, anti-aromatic and non-aromatic. Let us move a step ahead and think more. So let us 7-member ring, a highly stable structure in organic chemistry is this tropolium. So this is the first 7-member tropolium. We also have another 7-member tropolium present here, which is popularly known as a tropolium cation, and we have another very typical structure that we will coin it as Tropolium Anion. So it's an anion, a cation and a simple tropolium. Looking towards the very first structure, that is tropolium, it has sp3 carbon, which directly makes it non-aromatic by nature. On the other hand, this structure 2 pi, 4 pi, 6 pi and a positive charge. So it's a 6 pi electron system, and over here it's a 2 pi, 4 pi, 6 pi and 2 pi, 8 pi electron system. Whenever I say a 6 pi electron system, it will always follow the rule 4n plus 2 pi electrons. And whenever I say a 8 pi electron system, it will always follow the rule 4n pi electron system. Over here I will take n equal to 2. Over here we are supposed to take n equal to 1. So this will lead us to two different very typical answers. Aromatic, and the second one anti-aromatic. So friends, this easy is classifying the basic questions related to aromatic, anti-aromatic and non-aromatic. You should just know the shortcuts. Finding just a single sp3 carbon in the complete structure makes it non-aromatic. If there is not a single sp3 carbon, you have only two choices left, and that is aromatic and anti-aromatic. Go for three fundamental things. It has to be flat, that is planar. Alternative double bonds has to be there, and all carbons have to be sp2 with an exception of a carbon with a negative charge. If these three conditions are common, then you have two parameters to be checked. 4n plus 2 pi electrons for aromatic and 4n pi electrons for anti-aromatic. So this is a 7-member ring structure, and now we have a very popular 8-member ring structure where your marks can be lost. See how marks of a student who is working too hard in the competitive exams related to chemistry can be lost. I have this structure. Whenever we have this structure, it will be mentioned as cycloocta tetraene. Looking towards this structure as the first shot, our observation will be number 1, no sp3 carbon. And whenever we see no sp3 carbon, the first thing that comes in our mind is ये non-aromatic नहीं होगा. It will never be non-aromatic because Sir has taught us, Sir has discussed with us that to be non-aromatic there should be a minimum sp3 carbon, and it does not have a single sp3 carbon. So the whole attention of ours from non-aromatic will go away, and we will start thinking in the direction anti-aromatic and aromatic only. These two will be in our mind, and then when we will look towards the number of pi electrons, 2 pi, 4 pi, 6 pi, 8 pi, जैसे ही हम 8 pi electrons देख लेंगे, our whole focus will move towards the formula 4n pi electrons, and when we will see 4n pi electrons, we will just pick anti-aromatic, we will remove aromatic, and our answer will be anti-aromatic. But friends, be very particular, this is not correct. Why? Because in an organic molecule, when the number of carbon atom exceeds 7, when the number of carbon atom exceeds 7, it is really very difficult to get a planar structure. ज़्यादातर structures non-planar हो जाते हैं. Most of the structure becomes non-planar, and so when the structure becomes non-planar, definitely yes, आपका आंसर अपने आप क्या हो जाएगा? Your answer on its own will become non-aromatic, which you eliminated first. And henceforth, whenever this question is asked in the exam, cyclooctatetraene, always prefer it to be executed like this. And when you execute this structure like this, the probability of making it wrong will be vanished completely, because ये इतना part ही planar होगा. This is out of the plane, this is below the plane. So this is how this particular structure is beta non-aromatic and not at all anti-aromatic. So friends, whatever we saw up to this particular point in this session is all part 1 of this video. I'll be coming up with another video, another discussion on few important questions of aromatic, anti-aromatic and non-aromatic in the second class, second video, soon after this, where we'll be solving few exceptional cases. And when we solve these exceptional cases, you will get an idea how to attempt such scoring topic in your exams. Thank you for watching. Thanks for your support.